Zellner, today's speaker. I met Moira last summer at a conference at the National Science, NCSE, National Council for Science and the Environment, and she gave a short presentation at that meeting. I was just blown away. I thought, this is someone who's doing really interesting work, really visually appealing. I would love to bring her to Tufts. I think it would be of interest to multiple programs and departments, students. So thank you for saying yes. So Moira was born in Argentina, and she got her undergraduate degree in ecology. And I'm thinking, as an ecologist, why would anybody want to leave ecology? And she said to me this morning, I don't like counting things in the field. And I said, okay, that's why you go to undergrad, and you decide if you like counting things or not like counting things. So she decided, but she really wanted to try to do some work that allowed her to put pieces together and plan forward and make an impact. And as an undergrad, they said, you need to be in urban planning. And she said, huh? Urban planning? So then she started looking into it and found, indeed, the kinds of skills that she wanted to develop were based in an urban planning department. So she got her master's in urban planning, and she got a PhD in urban and regional planning, and she also has a certificate in complex systems modeling, which I thought, so this could be a really complex talk. But this morning, she told me that the best modeling is simple, that nothing good has come out of a really complex model. So I think it's really interesting to think about how we try to understand who we're working with, the participatory modeling, trying to make solutions that can be understood and appreciated and acted upon. So thank you for coming to Tufts. It's great to have you.
Thank you so much. Thank you so much for inviting me to be here. I'm excited to be here. And you know, I know that I'm competing here with pizza, so it's going to be tough to get your attention, but I'll try. So thank you, Colin, for that introduction. So I've tried to combine the tools from complex systems modeling and then my background in ecology I'll keep going. And my background in ecology to build into urban planning and create tools for urban planning and decision making. And the reason why I was interested in this was because I started out, again, learning about complex systems as an ecologist. So thinking of how different parts interact with each other to create a self-organized system. And, cities are not very different in that sense. They are formed by multiple, agents and actors that interact with each other. There's nothing really governing a city or driving a city. And so if we can, maybe there are ways in which we can use this idea and this concept and the frameworks and the tools of complex systems theory and studies to try to articulate the social, the human side of things and the natural side of things. So I think this actually is more competition than pizza. So maybe I'll wait a little bit to just make sure everything works. Maybe not. So, I'll keep talking. So, so this is where my past also in performance arts comes. So if I have to do interpretive dancing, I'll just do that. So anyway, so as an ecologist, then, the driving questions for me, for the work that I do, started when really I was 16. I remember this particular time in my life where I was in high school, and, I wrote down in my physics book, I, Moira Zellner, will be an ecologist. And as I always say, needless to say, I wasn't the most popular girl in high school. But, I really, at that time, I really became very aware about sustainability issues. And are you going to, Okay. So and so the big questions for me that, you know, have driven my interest and that, you know, decades later still persist are like, you know, big questions about complex problems that have to do with, you know, persistent poverty, persistent pollution. We've been facing, of course, we've heard endless times now about, you know, climate change, although amazing that it's still a debate. But we're feeling the effects, and despite all our technological advances, we don't seem to be making a lot of progress in terms of, you know, how do we address some of these problems. And some of them are social, like, you know, like hunger and crime, and again, like or corruption, we were talking this morning about that, and how pervasive they are, how difficult they are to eradicate. And so when I, you know, combine all this background that I was telling you earlier, I really focused on creating and developing tools for modeling some of these complex issues and trying to address some of the questions that we see in planning. And especially because when I entered into the planning field, I saw that there were all these assumptions being made about what should work, because, hey, it makes sense. And so, you know, talking about sustainable growth and what is that like? Or how effective is green infrastructure? And assuming that, well, if we have green infrastructure, then we can, you know, deal with flooding, for example. Or like, you know, balancing local economic interests with regional environmental goals or conservation interests. Managing flooding and drought in flatlands, in flat agricultural areas. So a lot of my work has been about, you know, creating these couple human natural systems models that represent the complexity of the socio-ecological system, representing the actors, the decision makers, the institutions, but also the environmental processes that they are affecting and that in turn affect them. So let me show you an example of the kinds of models that I create. And so this is built in NetLogo. I don't know if people are familiar. So yes, there's like excitement here. It's like geeks like me. So this is built in NetLogo. It's called the SUM model. It's an original model that we developed for exploration of exurban development and what are the decisions that made at the very individual local level that lead to different kinds of urban patterns. And here what you see, although it doesn't show very clearly in the display here, but different shades of green that represent an exurban area, and the brighter green represents like higher quality, ecological quality, which is one of the reasons why people want to live, you know, outside of the urban, dense urban areas. The red square is like an initial commercial center, service center, employment center that you can see, like say, like a mall or an office building, something that sprouts in that area as a new center of development. And so what I will show here is just one simulation, one history of different residents coming in, the gray houses that come in and looking to balance, they value equally being close to the red squares which provide urban amenities, but also trying to capture the bright green as they're looking also to balance that need for ecological quality. And I can run it multiple times and the history will be slightly different each time because they're not like optimizers. They have like bounded rationality, meaning that they don't have perfect information, which is typically what happens. We don't have perfect information about where we are going to locate or like the market. We sample that space, right? And so here they sample the space, and that's why every time it's a little bit different, because there's feedback in both directions. The residents are following the red squares, the commercial centers, but the commercial centers are also following residents. They don't want to be too far from them. And so because of this, you know, this interaction, there's path dependence, and it's a little bit different each time. But the pattern in itself, it's kind of similar. What if I changed, for example, the residents' preferences? So they don't care about being, you know, close to red squares. They care about just ecological quality. The pattern is completely different. Everything else is the same. The rule of decision making is the same. It's just that they don't care about being close to the service centers. The service centers do still follow residential development, but now the residents just locate where? In the areas that are just bright green, okay? And so it might be different simply because the landscape is different each time. But again, like, you know, the pattern is these clusters around the bright green. What if I add another layer of complexity to this, which is feedback? You know, when we develop, we deteriorate the environment a little bit. If I don't change the preferences, they only prefer natural beauty, how would this pattern be different? Well, let's try it out. So here I have a switch where I introduce that possibility of feedback. And this is the outcome. So what's going on here? Any guesses? Why is this so different from the one before? Yes? Right, exactly. So they deteriorate the environment, which reduces the level of green, if you will, right? And so the subsequent residents will move further and further and further away. And so then what happens to the pattern? It sprawls, which brings a whole bunch of other problems. But then what happens to the environment too? It's widespread deterioration, right? So I use and I build these kinds of models, and I can make them more, geographically relevant. And I can use also survey data or some kinds of, interview data to try to inform the social and the decision-making side of things. But these are the kinds of models that I've built in order to try to address some of these questions. And so I did publish some work on, coming up with answers to some of the questions, which, for example, growth is not sustainable, period. That's why it's in brackets. So let's stop talking about sustainable growth. It does not exist, period. Okay? And I can share that paper that shows an example of how that cannot be possible. Questions about green infrastructure. There are thresholds, and spatial layout of green infrastructure will affect its outcome. In fact, there's some layouts where we can invest a whole bunch in green infrastructure and it's completely useless. Okay, so where we put it in space and how much of it we put matters. So that's other publication. Then looking at the collaborative, how collaborative conservation can arise even under development pressure, depending on specific initial conditions of the assets available and the policy interests and preferences of municipalities. And finally, also looking at adaptation and how it can reduce crop losses, but also exacerbate flooding in flatlands. And so that's a publication that 2019 is a question mark because I still have to submit it, but it's coming, it's coming. But despite, like all these efforts, what I noticed also, and not just my efforts, but, other people's efforts, is that we're generating this knowledge, and yet there is little uptake into the policy world. And the reason for this is one of my early, thought articles, is that what tends to happen, I think that we're moving away from this, but I still see it a lot, is that, we've got the policy-making world that is separate from the science and the modeling world. And so the policy-making world is usually perceived as like this messy thing where we discuss values and demands, and we try to design policy based on these demands. But, these demands also generate questions about, okay, but given the demands that we have, which typically are, how can we grow? Okay, how can we make more money? How can we have more economic activity, et cetera? Then going to the scientists or to consultants, et cetera, to do their modeling and give us answers about, what the possible scenarios are, how can we do this, what are some impacts, et cetera. And so the scientists go into their dark room, windowless room, with all these servers and stuff, and they do their, modeling and crunching and all of that, and data crunching, and then they come back with answers. But in order to be trusted, they have to be very accurate, right? So the emphasis is on accuracy. But in order to do that, the demand then on the modeling side of things is that it has to be complicated, it has to be detailed. And then it becomes very quickly a black box. And so only the modelers understand that black box. And it's hard to open it up and inspect it. And what that does is that it keeps the discussion about values and goals separate from the discussion on process. And how do we need to do things in order to get to where we want? And so there's no possibility there of learning and questioning our own goals, because we don't understand how our own goals are driving us to extinction, essentially. Okay? And so why it is that, our goals are the problem. And so then we have a discussion about values. What is not happening is just collaborative learning. And where we are all stakeholders, where we're all, building perhaps models together and jointly learning and innovating. So we learn about the space, we can build these tools where models become boundary objects around which we can have discussions not just about process and how the world works, but also how we want it to work. And what are things that we might want to change, or what our goals might be. So there's this missed opportunity of, really learning together, but also generating trust, generating collaboration, generating innovation in a more co-evolving and adaptive kind of process. So this is where I wanted to go and where I saw an opportunity, especially with the kind of modeling that I showed you, that I felt, when I was working on my dissertation with this for the first time, I was working with planners, and when I was sharing with them, the model that I was building, the agents, their preferences, how they were making decisions, it felt like they could relate to that model better than, say, if I showed them a bunch of equations, which would have been very hard to communicate and have a discussion on. Now, that was my goal, my desire, but then, of course, there are challenges to that. And definitely, the setup that I was proposing it's an interdisciplinary setup, and it's an intersectoral setup, because you have scientists, but then you have non-scientists, you have decision makers, you have the public, all working together. And so there's a challenge there to communicate across these different realms. And I have many stories that I can share later if people are interested on some of those. But then also, of course, if we're using computers or if we're using, some kind of technical approach, spatial thinking, computer modeling is difficult for most people. I mean, we have these things. I have one of these, and I still don't quite know how it works. And we have some challenges with technology. The one that I like the best is confirmatory bias, and I've seen this so many times, where, what does it mean? I can have the best model in the world, but if whatever the outputs are don't align with the user's beliefs, it's crappy, and then, there are all these questions, and no, it's not good, you forgot to include this and that and whatever. It can be the worst model in the world, but if it produces results that align with my beliefs, then I don't even inspect it. Okay, it's good, that's it. And so that's also another challenge to deal with. And then finally, one that I see very present in planning is this idea that, consensus building and the need to build consensus so that we all agree and can move forward. The problem with that is that in order to get consensus, given the diverse society that we live in, given the diversity that is represented in any complex problem, is that in order to avoid conflict, we have to generalize whatever the recommendations are to the point that they're useless. And I've seen many, many, many plans, environmental planning plans, that are completely useless, because the recommendations are, we've got to do sustainability, we've got to do green infrastructure, but they don't really provide a way to say, what does that look like on the ground? How do we operationalize these ideas? They don't give recommendations about that. And that's where the conflict is. In order to reach consensus, we have to, just agree at this very high level, which then means very little. So it's very generalized, too generalized to be useful. So this led me to the other side of my research, which is moving into how do we create tools for participation? So how can complex systems modeling help us learn became my goal. And how does learning lead to better planning, deliberation, and decision making? And this also emerged from, really seeing this as a social learning process. And this is also where I learned a lot from colleagues that I collaborated with in learning sciences. So that really has been an incredibly fruitful collaboration. And in fact, a new panel is coming up in the ACSP in the planning conference this year, bridging learning sciences and planning with some of my colleagues. So we've built an approach, several approaches actually, to support learning and innovation, and it does happen. We've seen that happen, we've had evidence of learning, but it was very hard. And the reason is that in most cases, what happened, and goes back to the confirmatory bias thing, is that people then expected for their favorite policies to work, and then they saw in the modeling that they wouldn't. But that led them, instead of thinking of new ideas and new policies or planning approaches, it led them to depression and hopelessness. And so what's the point of learning if we get so hopeless and depressed that we're paralyzed? Or we either deny the whole thing and just say well, your model doesn't work, or just well, we're messed up anyway, so let's just wait and let disaster happen. So that's not very helpful either. So we left that, but I'll share with you two stories of how the evolution of how we came up with the approach. But what is important to understand is that this is a deeply human experience. And so it's not just about the tools that we develop, but like the whole structure around it of how people use the tools or how can they use, so that when we design tools, we think about this human activity, okay? So it's not about the tools. So a lot of the work has been on the northeastern part of Illinois. This is like, you know, Cook County and like where Chicago is, and then some of the southern and the exurban districts that we worked in. So the first is about, you know, where we started, which is groundwater supply. And this is where we go back to, like, you know, the simple models. And so we created a structure of, you know, subsequent meetings, like say 4 meetings, where we thought that we could introduce stakeholders to just, you know, agent-based modeling, how you can couple human natural systems dynamics, have them give feedback, you know, and inform the process of modeling, and tell us, you know, how should we adapt this to fit, you know, your communities, so that they reflect what happens in your communities. But for them to understand, like, you know, that decisions at the very local level can build up to system-wide effects. And so we introduced them to the SUM model. We showed them how preferences make a difference. Then we overlaid that with a very simple groundwater flow model. And because, well, that was what they were dealing with, and especially in the exurban areas, adding some graphs here that represented the variables of interest for them, which was like how many people would be in deficit, what would be the area that would be in deficit as the groundwater is drawn down. And then finally, you know, like informing it with more detail, like about this particular county. And here, like the different colors representing, well, are they connected to Lake Michigan? Okay, so then they are not affecting the groundwater, but the rest of the county is. And, you know, you see widespread deficit here in like the dark spots. And so what we found is that by going through this progression and trying to teach them, you know, like some of these, how to use some of these tools and explore different policy scenarios with them, they really, you saw evidence that they were learning about this, that there was a transparency in their assumptions now. And so even like from the beginning, in some cases, they were even questioning whether, you know, groundwater sustainability was even a problem. But going through and working with the modeling actually brought up the question from some of the other participants saying like, no, wait a second, we are actually doing conservation, and why are we doing it if, you know, if it's not a problem? And they were able to have this discussion around the model. And then, or assumptions in terms of like, well, you know, we don't have any growth here. We don't want it here. In that particular area, it's a very wealthy area. They wanted to exclude growth and have them not affect their water resource. But then again, as we were talking about it, then, you know, they were like, oh, okay, actually there is growth. You know, when we were representing it and showing it to them, like, no, actually this area is growing here and here. I'm like, oh, okay, so then growth does happen here. The neatest thing is when they start engaging in mental modeling. So once they understand how water flows in an aquifer, for example, they were able to anticipate without modeling that if they made certain changes, then how it would affect the aquifer and the levels. And so because there were some options to hook to Lake Michigan in some parts, but they were saying like, oh, but that's downstream, so it's not really going to affect, you know, the levels upstream. And so they were able to understand that and anticipate that. Again, getting to the doom and gloom side of things, realizing that their favorite approaches wouldn't work the way they expected. And so there's the idea that whatever they were proposing, usually cluster development at that time, was going to work, and seeing that it wouldn't. And also for those who were rejecting growth and trying to isolate themselves from their neighbors and the effect of their neighbors, realizing that they share the aquifer. They're not going to be able to isolate themselves from neighboring effects. And if the neighbors were growing, then they would be affected too. So they had to work with them, which they did not want to do, okay? And then the nice thing also about it was that the tool allowed them to become like much more specific about the solutions that they could come up with. One of them really is like, oh, well, we've got to work with our neighbors. So realizing that whether they liked it or not, they had to engage in conversations with them. But then it's like, what are we learning? Well, that, you know, we could do recharge. And that was an interesting side of things, that they could, you know, they were still focusing more on like the supply side of things. They never really discussed the demand side of things, but at least they were becoming more concrete about where they needed those recharge areas to be. How big should they be, considering that there are like things like time lags in terms of recharge, their rates of recharge and things like that. So they were able to understand and become more concrete about that. And then finally, in another group, it was interesting that people said something like, well, you know, I wouldn't say this in a public meeting, but how about this new idea about, you know, doing groundwater injection, which is actually done in the Southwest, but, you know, not in the Midwest. and it brings its other problems, but at least it provided a platform for people to just think outside the box and propose new ideas. So that was good. But even all of that, even after all of that, and all the evidence of learning and coming up with policy and planning innovation, they still tended to reject or dismiss or like not value enough or not see, like how they could use this approach in planning. And so we wrote a paper about that. And in particular, there was one group that was a little bit more contentious, where again, like they dismissed the model thinking like, like it's inaccurate, even though we had put in the model everything that they wanted us to include. So what was going on? One of the things that we developed with the learning scientists is using tools from learning sciences to understand how people learn. And here, what this represents is like the 4 meetings, the progression of 4 meetings in one group. So 1, 2, 3, 4. Oops, sorry. And what this shows is the frequency of each kind of discussion that they were having. About what? So the different colors are, so the pink is the model, is talking about the model. The purple is talking about policy. And the green is talking about the world. And I'm going to focus more on those because what we wanted to see is a shift from pink to green and purple. So instead of like just being able to talk from the model and learning from the model, but then shifting to the real world and to policy, okay? And so we see a little bit of that in the first meeting. So a lot of talk about modeling and then a lot of talk about policy, but that's kind of cheating because, we had set up the first meeting to talk about the policies that they wanted to see. So that's why that's coded that way. But here in the second one, again, like we're introducing them to a new version of this model based on their feedback, and there is some more discussion about policy here. The third meeting was really the best one. Again, like we got feedback from them about what they wanted to see in the model. We introduced it, showed it to them, and then they were able to transfer a lot of that, from the model into the policy in the world and look at it and implications here as well. And then the fourth meeting, it kind of deflated. As you see, there's much less dialogue about, anything. And what we have been doing up to a point is just keep adding their feedback and what they wanted to see. This is another way of representing things, and that same information, but now instead of looking at the target of their information, it's like of their dialogue, it's the kind of dialogue. So we coded for things like, are they objecting to the model? Are they asking for clarification? Are they clarifying something? Are they asking for an explanation? Are they explaining something? So those were the things that we coded for. And here, what we did was focusing on model objections, because we're thinking if they're critiquing the model, what does it lead to? Does it lead to talking about the world and then implications for the world? Are they talking more about the model? What are they talking about? Again, we want to see them talking more about the world and the policy based on what they discuss about the model. And so here the focus is world, going from model to maybe world and policy. And so we see here in the first meeting, there's more talk about the model clearly. Second also as well, but we're starting to see a little bit more about, the world and the policy. This is the third meeting I was telling you, like again, a lot of talk about the model, but much more about the world and the policy. That really was a very productive meeting. And in the final one, again, like we see this deflation, like, there is not as much talk as before. And we left that process hoping that we could continue working with that particular group, and again, it just kind of like fizzled out. And so I was thinking, well, what happened? What could explain some of this? So on one hand, so reflecting upon this. So first of all, the methodology allowed us to kind of like formalize our intuitions a little bit more of what happened during these meetings. So coding and displaying the information of the dialogue that way allowed us to identify that, and then going to like explaining what happened. So we went from simple interfaces with just one landscape, a few levers and graphs and things to manipulate, to very detailed, lots of levers, lots of things to move, that they wanted to see, like, moving policy, zoning, etc. And then lots of graphs to look at the multiple dimensions of the interactions. And they were all, grouped in small groups in a workshop setting and sharing these laptops and trying to make sense and manipulate these models. We went from relatively simple processes that fit in one screen to processes that drown the slide, and again, it's like this one of these papers that I don't know when I'm going to publish because I don't know how to make that figure fit in the paper and make any sense at all. So, the first lesson is keep it simple. Okay? What happened here is that it became just so complicated, even though they had, the stakeholders, the participants had, informed all this model, and we kept adding things because we wanted them to trust it, right? But what kept happening is that it just became more complicated, more of a black box, more difficult to make sense of. And when they couldn't understand why their favorite policies wouldn't work, then they just like dismissed the whole thing. So the first thing to learn is, like, if we want participants to engage in this process, to understand, be able to track the consequences of policies and decisions, it has to remain tractable. It has to remain simple enough, yet complex enough to capture like the essential interactions that matter, right? We also moved to, working in pairs around our laptops. It's just not a good setup. So we needed to move to tangible and collective interfaces that people could interact with, which we developed, and I'm going to show you in a little bit. And then also that it had to be more of an interactive, self-contained experience instead of like setting it up as a series of 4 meetings progression, from simple to more sophisticated, where, it's more of a teaching setup, not a planning setup. So it worked for learning. They learned, but it didn't work for planning. And so we had to change the whole setup and go more like, as we say, the opera talk show style. And so that's kind of what we did. And then we also were working with external partners, agencies in the region. And when they saw our progress, they said, you know what, this is great, but how about you move to a more visible problem? So it's the tangibility also of the problem that was an issue. So groundwater is invisible. You don't interact with it directly. And so it's hard to kind of like even trust what the model is showing. Flooding you see. And flooding, people can validate your simulation just because of their experience of where flooding happens, right? So that's why we went to this other setup and really focusing on flooding as an entry point to working with these tools and with complexity. So we built a model that here I'm just showing a simulation, and just to give you a sense of what this represents. These are streets around urban blocks. The dark gray are buildings. The light gray here are like, driveways or patios or things like that. There are alleyways in between. This is in an area of Chicago called Blue Island. And you see here the cross-section of and these are sewer intakes, and there's water coming from upstream and then also like going downstream from here. And what you see here is a cross-section, so you see that it's sloping, and this is the lowest area, and this is why it, ends up in a storm, it ends up flooding all this eastern portion, and then some of the buildings are flooded, and so they become pink to show that they've been damaged by flooding. So, okay, so suppose that we have that problem, we have this flooding, and now we're going to the exploration of, okay, how do we use green infrastructure? There was a big push in Illinois and Chicago to use green infrastructure as a way to handle stormwater. So, okay, so let's look. There are 2 different scenarios. In the left, we have a scenario where we have like all rain barrels wherever there are buildings. At the right here, we have like some bioswales or vegetated gardens that are acting as sponges. They're engineered soil, etc., that are scattered throughout the landscape. And they have different impacts and different costs. So in the baseline, with no green infrastructure, of course, there's no installation cost. But there's $39,000 in damages from the storm. And the 62% of the precipitation goes downstream to the neighborhood downstream. If we install rain barrels all over, we spend $14,000, a little bit more, but we barely make a dent on reducing damages, and we don't have any effect on the stormwater going downstream. Bioswales, we make a big investment here. This figure here represents the present value of 20 years of installing and operating and maintaining bioswales, right? So it's much more expensive, but it does reduce damages per storm. This is per storm, so actually we should make it more comparable. But it reduces the damage per storm by more, and it also reduces the runoff downstream. So the question is, which scenario is better, in your opinion? Do nothing? Could be. Okay, but you're a resident and you're being damaged and you want something done, right? What other opinion? You think bioswales, okay. So there are co-benefits that are not represented here. Yes, in the back? The bioswales. Well, of course, I'm talking to the wrong crowd, right? Because you're all like environmental people. Anybody for rain barrels? Come on. Okay. Yes. Why?
I'm imagining that given the cost, that there are other things you can do, right? So that if you're limiting the small.
Yes, it's a very small.
When people do that, you say, well, it's not like it's all impact. So you take the state money, it's not such a big difference, and apply it somewhere else to make people better off.
Right, exactly. So, for example, what if you're a public official and you only have $15,000 in your budget to do something? Okay. What if you're the hydrologist or the environmentalist and all you care about is like the co-benefits but also increasing infiltration? What if you're the resident down here, no matter what you do, I'm still getting flooded and I hate you all? Okay. So it depends on who you are, what the better solution is, better for whom and when. Okay. So simulations are not enough to provide answers. And it is because there are trade-offs. Some people gain, some people lose with each decision. And it depends on our values. It depends on the costs and how they're distributed, and not only across the population, but over time. There may be spatial constraints. So bioswales are great. I love bioswales. But, you know, we do have utilities underground. We can't always dig, right? So it's like, what do we do? I mean, we could, but then that adds to the cost, right? And there are diverse stakeholder interests. People want different things. So you might value the co-benefits, but a lot of people might not even care, okay, because it doesn't affect them in particular ways. So it's not just about solution building, but it's also about providing a support to build compromise, which means knowing what we give up and what should we do about it, okay? So it's not about, you know, finding the best solution, but a solution that we can all live with. And for that to happen, first we have to be aware of our preferences, our own preferences. Sometimes we don't even know what our preferences are, let alone the preferences or values of other people and why they have them. So we needed to, you know, expand the simulation with ways in which we could make that more apparent and address diverse needs, create new metrics, create a way to allow people to explore different scenarios and evaluate them according to their preferences. So we created this workshop setup, which has all these interfaces working together around the simulation that I showed you before. And it combines things that are traditional from planning, but with all these, you know, these new elements to it. And so the first, what we did is with my colleague Leila Lyons, who's in computer science and learning sciences, we developed this mobile app that has different functions. And so one of them is to rank these different priorities. So there are like hydrological variables, there are money variables that have to do with installations and things like that. So for example, if I'm the public official, I would rank on the top all the things that have to do with minimizing installation costs, minimizing investment, etc. If I'm the hydrologist or the environmentalist, I would, you know, put up top all the infiltration, you know, variables and things like that. So depending on who I am, if I have one of these iPads, I would rank things differently. And we developed these variables, and we chose these variables with key stakeholders. So we were developing all of this with our partners, external partners in the region. Once people do that, then they work around a map, a paper map, that is a representation of that landscape that I showed you in the simulation. And we built different tokens that represent different kinds of green infrastructure. So there were like green roofs, there were rain barrels, there were permeable pavers, and the bioswales. And so together, around that map, people could, the participants could create scenarios for green infrastructure for their community. Then we have another part of the app that takes a picture of that, and it becomes an input to the simulation. It loads it up in the model that we built. It runs it in a couple of minutes, and it produces results. And this is the setup that shows, you know, working with the map together. And so it takes a picture, runs the simulation, and it projects the simulation on a screen. And we're thinking, well, I was talking earlier with Kyle about how we can use, you know, augmented reality to make this a little bit more, you know, seamless. And then once you get the simulation run, it downloads the results onto the iPads. And so here you have each row represents each scenario that they tried. The first one being rain barrels everywhere. The second being a roof tops in roof gardens, like on a corner of the neighborhood. This one, bioswales distributed throughout the neighborhood. And you can see this clearly is a hydrologist or environmentalist because they really like this one, the one with the bioswales. They don't care as much about the cost. This bar represents like a composite score, and it uses the weights generated by the first page where they rank the variables, and then the results from the simulation to say like, okay, this is the one that is my favorite, so I'm going to click the heart on it. This one's my least favorite. See, the bar is like very, very short. I don't like it, okay? But it lets you see the raw results as well, you know, and there. But you can scroll to the right. The first ones that you see are the ones you care about the most, but you can scroll to the right and see the others. And then the final page of this is, how does my valuation compare to the valuation of others? So here we have two participants represented, the pedestrian and the politician or the policymaker. And of course, the policymaker loves the rain barrels. Why? Because it's cheap, right? The pedestrian hates it. Why? It doesn't work. Doesn't do anything, right? I still have to like wade through the rivers of, you know, there to get through, okay? So that's why I don't like it at all. And nobody likes the roof gardens because, again, they don't do as much. They don't have capacity in terms of flooding control, okay? And they're very costly, so nobody likes that one. And so what this allows to do is quickly identify, well, you know, maybe we should just kind of forget those because they're not good for, in general. Let's look at these ones because we tend to favor them more for different reasons. Let's see why. And so you can start discussing like what are the variables that are important to each other, you know, to each one, I mean, so that we can discuss like, okay, well, this one's really good for me and I like it because it really addresses, this one really addresses the problem for me. It reduces flooding, I can walk through the community, etc. Hey, but it's costly. Okay, so I gain a lot, you don't gain as much. Should I compensate you? Or should we go for another scenario where it's a little bit more equitable? It doesn't benefit me as much, but at least we don't have to, you know, argue or bargain or anything like that. So it allows for that kind of conversation to happen and really making the trade-offs visible and having a conversation again of like going back to the idea of like, what do we give up and what do we do about it? So it goes back into, you know, this deliberation that can go back to like with an understanding of how the water flows through the system to the redesign of other scenarios, or even maybe reshuffling your priorities when you start to understand, hey, you know what, that pollination thing is actually an important thing for me and I hadn't realized, okay? And so being able to have that space to have that kind of transformation. And so again, what we see here is evidence of learning, innovation, and compromise. So there's the assumptions become more transparent as well as the trade-offs. So we have, you know, this dialogue of give and take of like, well, it's great for you, but, you know, not for me. So it depends on who you are. Or this was great to reduce damage, but in order to reduce damage, we had to go over budget by like $1.something million. They did engage, and because we also, you know, set up this with a very defined facilitation structure, which we hadn't started with. But as we tried with our stakeholders to do this and I would say like, oh, let them play. No, let them play. There are too many moving parts. It's too difficult. So we created a facilitation structure that made it easier for them to explore the space and to come up with solutions. And so they really engaged in that kind of systematic exploration. The one that I like the best is, again, like being able to start doing mental modeling and using gestures to, before running any simulation, they didn't need to run simulations after a while because they already knew what was going to happen. And so they would say like, oh, the water is flowing through here, and so we've got to put green infrastructure over here to intercept it. Or they could imagine like, okay, rain barrels, finally, they got it. It doesn't work. Okay, but what if we put 2 or 3 or more, or an underground storage tank? Like, oh, okay, well, then we have to start changing specifications, but also start changing costs, right? But finally, again, the doom and gloom, we always get there, is that the green infrastructure cannot locally solve the problem unless they spend a lot of money on this. So starting to realize that, well, again, one of the scenarios was looking at what happens upstream. If people do things upstream, it really helps us, so we should collaborate regionally. So that was, you know, part of the conversation that will come up. That they would need to combine green and gray infrastructure, maybe. So, you know, that it's not all about and putting it all on green infrastructure because it's not enough. but maybe starting to think of new things, like for example, hey, maybe we need to move people out of there because this particular region was called Blue Island for a reason. It was an island, there was water, so maybe that water needs to be there, and it's cheaper. And there were some communities that actually drafted plans after that. I don't know if because of our workshop, but they did come up with like really looking at that option, and they did it. They planned for it. Like moving people was cheaper, and creating a wetland was cheaper than insisting on retrofitting the place. And so what was interesting is that all of this realizations and insights happened within 2 hours of a meeting with these tools. So imagine what could happen as an ongoing exercise, and some people wanted to take it with them and continue playing. So, getting to the end of this, we actually got an award. I was very excited. We got an award from the American Planning Association for this work, on the Academic Tech Innovator Award, the first one, so that was nice. But what are some of the insights that came from this, the takeaways? So one is like how important it is to engage in collaborative design with stakeholders. These tools were developed with them, not for them. And I make that distinction because it's very, very important, okay? And it's what allowed it to work, I think, better than prior trials and other things that we do in the field. How facilitation was really important, and this is an area that we want to keep investing in. We have to find the right funding for it. But being the facilitator of these meetings is taxing when you're trying to synthesize all the information from the conversations that are going on, and so we want to develop better platforms to support that activity. Then again, like moving from consensus to compromise, and again, like that idea of like it's not about the best solution, but the good enough solution that we can all live with, and really focusing on like these concrete trade-offs and how do we handle them, and seeing this as a scaffolding process, where this is a platform that allows people to engage with the problem, to engage them with more sophisticated tools. There are many hydrologists and hydrological models out there, but they're very difficult for people to use so that they can understand why they have to do things differently, why they should want to do things differently, okay? And so this is one way to enter the problem and the space of tools available, so then they can understand more sophisticated tools and other kinds of scenarios that they can explore with them. And I'm talking about things like the SWIM model and things like that exist. It's also an entry point to diverse interests. Again, becoming aware of our own values, but also understanding that other people have other values and why. And then also to other complex problems. So then hopefully now we can go back to groundwater and other kinds of problems with this kind of setup. Why do we do this? It's a lot of work, let me tell you. And it gets, it is tiring. But it's also very exciting. And the reason to do this is because we have habits of practice that really prevent us from seeing and working with difference. And this is a way that we can harness difference and work with it, and rather than trying to push back the conflict, and really getting on like on the ground operationalization of things like sustainability, resilience, etc. So creating ways in which we support the evolution of both understanding of the complex biophysical process, but also the evolution of our valuation process as a collective, individually and collective. Here, technology is it's not about technological fixes, okay? Technology is a prosthetic device that supports the deliberative practice, okay? So it is supportive of decision making, and it's not like the fix or the thing that gives us the answer, okay? And this is critical for innovation, and innovation is critical then for sustainability, but also in the way that we're thinking about it is also in terms of the democratic decision-making process. So really supporting that kind of work. I don't work alone. I work with a lot of support and with a lot of funding from different sources. Well, not a lot of funding. I wish I had more funding, but definitely with a lot of people, and I'm always very grateful, to be able to work in these kinds of teams and put them together. And with that, I'm going to finish and thank you. And if there are any questions, I'm happy to.
Thank you, Moira. This was really cool. I love the tools, and I can think of many applications. But something that stuck with me is the importance of compromise.
Oh, yeah.
And I was wondering if you could talk a little bit more about, because you can produce a lot of solutions, a lot of numbers, but how do you go about when you have a couple of stakeholders are entrenched in their totally opposite
Yeah. We've got those.
positions.
We've got those. I let them fight it out. No, so I mean, we had a few cases where that was difficult, but interestingly, even when we didn't have this whole, support system, like with the groundwater especially, we had that, it was much more contentious than the flooding one. And in the end, it was the other stakeholders who neutralized that particular person, because they were starting to understand more about the system, and they could see why it made sense to do certain things, and also because the ideas were coming from them. They just worked it out as a group where, and then some left, actually. Some left the activity. They just did not want to continue being part of that. That happens too. But this is, it's still very new, and I wish I had many, many more cases to try this and tell you, in each case what happens. But there was one that I didn't show here, and it was with a different set of tools, but they were clashing, and they were not being able to advance because, one person wanted a particular, asset or amenity in a stormwater park that they were working on, and the other thought it was completely useless. So one wanted a nature center. I don't know why. Yes, no, yes, no, yes, no. And it's like, okay, let's think about, what does the nature center provide to you? And really shifting the conversation towards what is it that you need, instead of like, what is it about the nature center that you need, rather than stopping at, I want the nature center. And so she started talking about how it was a way that kids could learn how to grow food. This was a low-income community, and so access to good food and nutrition was an important issue for her. When she started talking about that, the other person started to nod. And so then there was like, oh yeah, I agree with you on that. And so then a third person said, hey, how about instead of building a nature center, because what this person was worried about was like you build a building and then nothing will happen. So then the third person was saying, how about you put in like a temporary structure, or you create first a program. I was also suggesting you create first a program with the schools, and you have the program, and you have a part of land where you can try this out, but it's not a permanent structure. Or then you bring a trailer in, and you do it in a trailer, and then when it becomes established, so you they started thinking in phases. Then, if it's established, then you can build, and with funding, you can build the more permanent structure, and then the conversation moved forward. So that's also part of so Colin, you had asked me about the Elementa paper, and so that's one of the things that we highlighted, which is, focusing on the needs, not necessarily on the wants or shifting it from wants to needs and like the fears, and really appealing to the emotions that are driving these conversations, because emotions are a huge part of this. That's one thing, it's a deeply human experience. So, the tools just by themselves are not going to do it. The facilitators are critical to this. And knowing to identify those situations and try to, okay, how do we synthesize and move forward? Mm-hmm.
I have a quick question. So you mentioned the facilitators, and you're very interdisciplinary. So it strikes me you'd be like the perfect facilitator because you have knowledge around a whole bunch of areas. And so if you want to talk about pollinators, you could put on your ecology hat and help guide that conversation. So to what extent have you bypassed the need to bring experts in to these conversations because you know enough to be the facilitator that can help them find other resources? In other words, how much do you need interdisciplinary training to play this role, I guess is my question. That's
a great question. So definitely I have built on my own interdisciplinary training. And I have built my own interdisciplinary training too, because it's like nobody necessarily taught me to be interdisciplinary. I just did it myself, right? But now there are more and more programs, and I think that this is attests to it too, that are more interdisciplinary. And I think that it's definitely something that is useful and very helpful in these kinds of situations. That said, oftentimes you do need different kinds of facilitators. And especially not just because of the expert knowledge in particular. So when I'm working in the collaborative design of the tools, I am working with different people too. But as you said, it really does help that I know enough about all these different things that I can communicate with all of them as I'm trying to integrate them into these models. That said though, there are other aspects of this process that are important and for which you might need specialized facilitators. And so in some cases, I'm a complete outsider. And I cannot be a facilitator because you need a community facilitator, okay? Somebody who is known by the community and who can actually help guide the process because of the relationships that that person has with the people from the community. And so we do that through key stakeholders, for example, and working with them, but then they become facilitators and advocates for the whole process and the use of the tools and all of that. And then sometimes you do need specialized, technical facilitators who, for example, are the engineers that are building the stormwater park. I cannot answer questions that they have, and so I have them there, like whenever there's a question, come on here, here you go, go answer this question. And so there needs to be some flexibility there. But interdisciplinary training, I think, is crucial as, maybe an umbrella for all of this. Mm-hmm. Oh, there's a question over there.
How do you see this playing out? Not just in these rooms where we're trying it out, but in the real world, when we have to be making the policies and stuff.
So we actually tried it out. So the way that we tried it out was in the midst of planning processes around groundwater and flooding. So of course they were trials because we were trying new things. But over time, and as we learned from all of this, and we were involving and using other kinds of techniques, we were learning and really inserting ourselves more and more into actual planning processes. And it's been incredibly productive. All the things that we've learned, we've put in practice, and they've worked really well. To the point where the Water Reclamation District, for example, that was building the stormwater park, they want us to keep working with them and replicate what we did in the whole watershed. And so now, of course, the issue is finding the funding to do that. But we were not even using these tools. We were using even less sophisticated tools than these. So yes, it's tried out. Yeah.
My question was, most of this process is a very human-oriented process, which is very good and makes the process very simple. But I was wondering to what...
no, the process is not simple.
I mean, it's simpler than it could be. But I was wondering to what extent you push for or kind of make accommodations for non-human entities, you can't just support a dam or something that would stop the water flow entirely, things of that nature.
Yeah.
So do you make pushes for that, or?
Oh, yes, I do. I'm a stakeholder. I mean, I present myself as a stakeholder, too. I try not to be too pushy about it, right? So I do it more in a subversive kind of way. But I do present my agenda, and I ask them, so what do you think about this or that? And usually they listen, and usually they incorporate it, and so it is my work also as a stakeholder to make sure that certain things that are important are brought up. But the idea would be to, again, this is, even though we create these exercises now as standalone, so that, because the idea is that whether they participate in that thing alone or not, at least they get something out of each and every one of the meetings. That we want to make sure of, okay? And hopefully by doing that, we also encourage them to continue participating. But the idea is to have this be a more long-term process where, you invite different people, and so they bring in their own agendas, and they can represent some of these other, aspects and trade-offs that need to be considered, So that would be the idea. Instituted as a practice. So it goes back to your question as well, really institute this process and the tools that go with them as a planning process, as a planning practice, that is an established practice.
Well, we should probably stop there. Thank you. Thank you, Moira.
No, thank you. Thank you very much.
I know she can stick around for a few minutes. If you have that burning question you didn't get to ask her publicly, I'm sure she would take it privately. Thank you again.
Thank you very much.
Got a great dynamic style.